That is a very important question. In fact, the best way to actually think about it is the amount of data that is produced and transmitted over the networks will only keep increasing. There is literally no end to it. And one way of looking at when we first started thinking about what sort of processing needs to be done in devices and what processing can be done in the cloud.
Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app. And we'll keep sharing great conversations like the one we have for today. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. I'm also an investor and an advisor to more than 30 AI-first companies, and of course, a firm believer in the power of technology to make humans better. If you're passionate about changing the world with AI or just looking for your next adventure, let's talk. We learn from AI thought leaders weekly on this show. And of course, the added bonus, you get one AI fun fact each week. Today's fun fact, OpenAI recently introduced Code Interpreter to much fanfare. It's now available to ChatGPT Plus users. Yuan Liu writes in the New York Times that it extends the capabilities of GPT-4 to include performing advanced calculations and generating charts based on data by writing its own code. Ask it an open-ended question like, what's interesting about this data? And it can do the work of a traditional analyst or data scientist. OpenAI continues to extend the boundaries of what next word prediction can do. Big impediments still remain like hallucinations, performance, cost, limited memory, copyright infringement, and biased output. But the pace of innovation is truly like nothing we've ever seen. As always, we'll link to the full article in today's show notes. And now shifting to this week's conversation. We have a special guest today who is commonly referred to as the Godfather of 5G. Durga Malladi is the SVP and GM for Technology Planning and Edge Solutions at Qualcomm, the iconic company, best known for enabling cell phones via its CDMA technology and chipsets that were first demonstrated back in 1989. Durga has been an integral part of Qualcomm's growth, having spent nearly 24 years there in various technology leadership roles. Durga holds 578 patents, is a senior member of IEEE, received his PhD in 1998 from UCLA, and was awarded Qualcomm's IP Excellence Award. Durga's list of accolades and accomplishments goes on for days. We're all lucky to be joined by a wireless pioneer and a true tech legend. Without further ado, Durga, it really is my pleasure to welcome you to the podcast. Let's have you get started by sharing a bit more about your background and how you got into this space.
Thanks for having me here, Don. It's a great pleasure, and it's really nice to be on this podcast of yours. It's my 26th year in Qualcomm. I just went past 25 years. Time flies by in this space. And for a majority of my career in Qualcomm, I spent time in wireless technology and its evolution over subsequent generations, starting from the old 3G days, then to 4G, and then evolving into 5G. But as Qualcomm gradually started looking at all the other ancillary technologies that are essential to make sure that we are successful in this space, especially as we empower devices and end consumers, we've kind of expanded our role significantly, both in terms of processing power, and AI. These days, I run our technology product management and across all the business units, the roadmap and the IP roadmap that is necessary to make these business units successful. So our spread of devices these days goes from handsets, compute segments, so this will be PCs, laptops, and tablets, XR devices, automotive, IoT, which can be consumer IoT, which goes down all the way into wearables and so on, or industrial IoT, which would be far more high precision. So equipment, Wi-Fi based access points and devices enabled by Wi-Fi, mobile broadband based fixed wireless access, and so on. So we have a pretty broad and diverse set of businesses, and there is one technology roadmap that spans and threads the needle across every single business unit. So in that sense, my role these days is a combination of connectivity, which of course includes 5G and Wi-Fi, position, location, and satellite communications, AI, which is probably one of the most important technologies that has emerged in the recent few years, and how it has the potential to transform the user experience when they start using these devices in a very different way. The processors that power these devices, so it's a combination of our CPU, our GPU, and DSP-based processors. Multimedia, which includes camera, audio, and video processing. Bottom line, it's a horizontal role that spans across every single business segment. But underneath it all, it's all about driving technology into these segments and making sure that from Qualcomm's standpoint, we are in a position to bring action into the devices as much as possible into the hands of end consumers to make that real big difference in terms of the user experience.
I mentioned before we started the recording that having grown up in San Diego, I've watched Qualcomm transform the economy and improve the lives of so many people that I grew up with. Having been a part of that culture since the early days, I would love to know, what's the secret? What has helped Qualcomm endure over a period of decades? And I know you've been there since it wasn't the powerhouse that it is today. So do a victory lap. What is it that's made a difference?
I think it is a very important part of who we are. Our culture was shaped right from the beginning, at the very beginnings when Qualcomm was founded. I wasn't around in the mid 80s when Qualcomm was founded, but Dr. Jacobs and Dr. Viterbi, when they started, it was all about an end-to-end systems company, which was all about asking the tough questions and never being afraid to innovate and go into domains where the problems are as complex as they can be and trying to find solutions in that space. From those beginnings, which is kind of a very high level, abstract, and yet even academic setting, over and over again, every decade as Qualcomm, we have found the ability to reinvent ourselves in a fundamentally different way. When the transition, we were at the forefront of the transition in the wireless space from analog to digital transition. That was all about voice quality and improving voice capacity. Then bringing data services into the wireless domain. There were two trend lines that were appearing in the 90s with the internet coming up, which is predominantly wireline in the beginning, and now we take it for granted in the wireless domain, with every device being in a position to consume data and generate data. But sometime about 15 years back or so, we also realized that at the end of the day, the data needs to be processed. And at wireless, at the heart of everything that is wireless, when data moves from one place to the other, there is a consumption that occurs in that space. And in that sense, it's a means towards an end goal. So we invested quite heavily into how do we process all this data that's in the device as it receives or transmits, and what happens on the other side of the link as well. And that's where the birth of the smartphone, as we call it today, happened. We reinvented ourselves into someone who could go really into processing technology as well. And a few years back, as AI-based technology started coming up predominantly in the cloud, when the original, maybe 10 years back or so, a lot of the focus was on image processing with the earliest convolutional neural networks that came up back in 2012, gradually going into audio-based processing, and LSTMs became the main theme sometime around 2016 onwards. And by 2018, when the original transformer networks came in terms of the beginnings of language models, which gradually became larger, and today in the generative AI space. From Qualcomm's standpoint, we have been focusing a lot on what sort of processing capability is necessary to shift a lot of the AI-based technology or bring it closer and closer to the end consumer so that we have the notion of some of the processing done in the cloud and the rest of it done on device itself. And so we are in that form or that phase of transforming ourselves once again as the enabler of AI in devices. That is the mission statement that we have as Qualcomm these days as we head into this space. It's been a fun journey in that sense. I kind of went through literally 2.5 decades of how much we have gone from those early days of a cell phone with CDMA to where we are talking about AI today.
We all owe a debt of gratitude to Dr. Jacobs. There really are very few tech companies that have touched more lives than Qualcomm. Now, growing up in the early days of Qualcomm, I still think of it as the CDMA radio modem company. And when you describe your role and where the company is headed, you said it's devices, it's AI, it's UX, all of which are not terms that I would associate with Qualcomm. So maybe say a little bit more about the technology roadmap and how that legacy CDMA company that I know is quickly becoming a leader in AI.
As we started looking at the next evolution in wireless technology with the transformation from 4G centric networks towards 5G centric networks, we were at the spearhead of that transformation, going into 5G technologies, extremely high data rates, lots of data being transported from devices towards into the network, and the network evolution in general. But along those lines, as we started looking at what is a better way of improving the user experience, because there are use cases that actually come out from these 5G networks, we started looking at AI has always been around in devices at some level or the other, starting from a few years back. Generative AI is only the latest instance of it. But if you start thinking about how images are processed inside your device today, a lot of it was already using AI a few years back. That part is not fundamentally new. But when we took a look at specifically in the context of generative AI and what we can do within the device in itself, well, that started changing our thought process quite a bit. There are use cases that they are really focused towards productivity tools as you're starting to use your devices in a very different way. This can be a smartphone in which you're simply trying to organize all the content in a better way. Or you can go towards an automotive use case where, without going into all the way to a level 5 autonomy, the basics of ADAS, a lot of the building blocks are based upon AI, whether it is multi-sensor input coming in from cameras, radar and LiDAR, or whether it is any other processing that you do inside the vehicle itself. One important aspect that probably is not as visible, but we did make an announcement about it is, even though we talked about AI quite extensively in a lot of domains that doesn't include wireless, starting from early this year, we made our announcement with the first AI processor, which is inside the core of our modem processing itself. Starting this year, we introduced it's the world's first tensor accelerator, as we called it, within our baseband modem. So it kind of gives a sense of when we think of, as Qualcomm, when we think of these different technologies coming together, we don't see them in individual silos. They permeate every aspect of what we are building within the devices in itself, from modem to your camera, to the audio processing, to any other productivity tool increase, and so on.
One of the things that confuses me is that I mentioned in the intro that you're the godfather of 5G, and so much of Qualcomm's recent business has been enabling additional services and apps to run on 5G, which would imply that you want more data flowing over those 5G networks and more mature 5G networks. And yet you just talked about enabling more capabilities locally on a device or potentially in an automobile doesn't that limit the amount of data that would be transferred over those 5G networks that you sold in the first place?
That is a very important question. In fact, the best way to actually think about it is the amount of data that is produced and transmitted over the networks will only keep increasing. There is literally no end to it. And one way of looking at when we first started thinking about what sort of processing needs to be done in devices and what processing can be done in the cloud. Now, let's take a very simple example. Let's say that you want to do all the processing in the cloud, AI processing in the cloud. Then effectively what it means is that everything that you have within the device, you're actually transmitting over the network. Whether it doesn't matter what it is. You're basically transmitting every single thing. If you take today's generative AI models, for instance, you basically enter in everything that you want and you receive all the information back. So that means the inference in this AI instance is really being done in the cloud and you just receive all that content coming back to you. That's one school of thought. But there are a few issues over there, primarily because the latency can be quite extensive, depending upon where exactly the device is and where the processing, the inference is being done in the cloud. That's one. Second, there's tons and tons of data, and it's not clear whether you really need to do it that way. Do you really need to send out all the information, or do you only need to send out the relevant information? And when you ask that question, relevant information, how do you decide what is relevant and what is not? So we started really paying attention to that. And as we started thinking through it, we came to the conclusion that perhaps one of the earliest steps is to say, we split the processing between what can be done locally in the device, and then the rest of the processing is really done in the cloud. As an example in that journey towards that, we can easily have a situation where we have inference running in devices. We are talking of smartphones, we are talking of laptops, we are talking of automotive for sure, inference run over there, and a lot of the training done in the cloud. That is a natural first step to take. And when there are questions on, is it even feasible? Because these language models or these LLMs, as they are coming out from multiple sources, by the way, there's tons and tons of models coming in every day. They happen to be somewhat large. Can you actually have the processing power to run it on your device locally? And the answer is absolutely yes. Some of our most recent demos that we did was to really illustrate the point. Yeah, we have reached that point where we can have low power AI inference with these large language models running on the device in itself. And it's been quite successful. The second part is, from a user experience, because it is running locally on the device, the latency kind of becomes academic at that point because you can actually see a significantly better user experience in that space. So this is the first natural step to take. The second step, and which is a little bit more out in the future, is a lot of the models, as they are trained, they are kind of what one would call as generic or foundational models. They're trained upon large amount of data, but there's nothing very specific about you as the end consumer. What you want to also have is take one of these very large foundational models and do some fine-tuning of that model based upon data that you are generating. Now that's more of a personalized way of looking at AI assistance, if you will. And that data is locally available. So maybe there is an opportunity at that point as we move forwards to start doing some of the fine-tuning as well, both at the edge of the network and at some point in time into the device itself, depending upon what kind of a device it is. Clearly, we are talking of a very broad spectrum of devices, from handsets to compute and automotive. So the processing power happens to be different in different kinds of devices. So there's a significant opportunity over there to move into that next step. But right now, we are firmly in the business of trying to bring that action as close to the end user as possible, starting with at least inference in the device and training in the cloud, and gradually starting to bring in some level of fine-tuning within the device itself. So that's where our real guiding North Star for us is going to be. This is the direction that we are taking, and we believe that this will be a truly transformative user experience from the end user standpoint.
The strategy makes perfect sense, but the implementation I imagine is tricky. So a few of the first implementation obstacles that come to mind are when we talk about a foundation model, or 7 billion parameter, BERT or llama model up to a trillion parameter GPT-4, which obviously would consume massive differences in memory footprint. And then the process, once let's say you manage to put an LLM, at the edge on the local device, that fine-tuning process actually requires, presumably, like you said, transferring the fine-tuning data over a cloud. But what's the process of then updating the app or the model on the device as it gets fine-tuned on inference and maybe other, fresh enterprise data? Just talk us through your vision for how that all actually works in reality.
Absolutely. There were a couple of questions in that one. So I'm going to actually with what are the kinds of models that we have over here. So let's take, you mentioned Llama. So let's actually double click on that. The first version of Llama, which had 7, 13, 33, and 65 billion parameter models. Suffice it to say that based on our capabilities right now, we do not see any showstopper for the 7 billion parameter models permeating into the kinds of devices that I was mentioning. Depending upon the compute platforms and so on, we can do even more than that. We do not foresee any issue with that at all. It's taken us some time to get there, but that is a pretty big, point that probably is not as well understood today. But over the next few months, as you start seeing this coming out, both in terms of our marketing demos with applications that are running on top of it, and eventually commercial products as they start getting launched, I think you will start seeing that, wow, I didn't know that this was possible in a handset. I didn't know this was possible in a laptop. I think you will be more surprised. So stay tuned on that. I don't want to give away the surprise over here, but stay tuned on that one because we've been doing a lot of work in that space. It's also important to understand that the KPIs that we have for this sort of enablement, take some of these model sizes that we are talking of, is make sure that the user experience remains intact. So the inference per second and power consumption also is very much under check. So we want to make sure that this is not something that will drain away your smartphone battery. And no, it is actually, you still have some expectation that in spite of running these large language models, you're not actually draining the battery significantly, and it remains in a typical user experience that you expect today these days. So that's on the, what sort of model sizes are possible today. We're not talking of sub 1 billion parameters. We are well into the 7 billion parameters, just in terms of the thought process that we have in mind. The second part is, how about fine tuning? Are we really talking about training in the device itself? I think the answer is twofold. There's a combination of training at the edge of the network, but not necessarily in the deep cloud. And then perhaps over time, depending upon the kind of a device, training within the device in itself. So let me give you an example on that. Take an enterprise. Now, let's say that you have a carpeted enterprise like Qualcomm, for example. Our CIO might want to have much better productivity tools for all of our employees, and yet at the same time, be very conscious of company confidential information on going out there. So you want to have, okay, we may have this notion of, let's take code generation or helping out from a code, I'm writing code and I want to have some help in that space. So in that sense, there is a lot of locally generated data, which is very specific to our domain. That's a place where one could easily see that the training can be done within a local server, which is, you could call that as the edge of the network. That's a very easy step to take. In fact, that is something one should be expecting over the next year or so, just in terms of how the traction of this can take off. But over time, you can actually take it to one more extreme and say, maybe I reach a point where I have my own laptop and I might be able to do a little bit more fine tuning because there's a lot of data now that's being generated over there. It's a little further out there, but it is most certainly doable, depending upon the processing capability that we'll eventually have in devices. Now, from just being in the industry long enough, I can just tell you this. In a lot of instances, as Qualcomm, as we start thinking in these lines, we always keep a very open mind in terms of, even though I mentioned laptops, I believe that there will be a point in time that we'll actually start doing fine tuning even within a handset in itself, even within a smartphone. That's just my personal belief in terms of where it'll be. But we have to have that sort of an ambition in mind to keep marching in that direction. At the end of the day, it's the application developers who finally then start shaping the user experience for the end user in itself. Because what we are doing is providing the capability for that. At the end of the day, that user experience is all that matters. Do I see a perceptible difference between I have an AI enabled smartphone versus, say, today's smartphone? I need to be able to see the difference between these two. And that's a place where we focus a lot with these developers and onboarding those developers. They need to know what are the capabilities of the device so that they can actually start building applications on top of it. So it kind of goes hand in hand from our standpoint.
But kind of like 5G required a device refresh, I'm assuming that between chipsets and batteries and storage, any of these new AI capabilities, it's going to require a hardware refresh, whether it's automotive, laptop, or mobile device. Is that what you envision?
We do believe that we are reaching that point where once we start seeing the art of possible in terms of AI capable devices, there will be this question of, is that smartphone AI capable? Now, mind you, if you were to really go into the technology, you would say even today's smartphones, of course, use AI at some level when it comes to photo editing and so on. But we are talking of, is it a perceptible, if this is an AI based smartphone and this one is not. Here's an AI based laptop, this one is not. There's going to be that moment in time where end consumers will start asking that question. And we are not that far from that moment. That's the way that we envision things.
Otherwise, you're just shifting the bottleneck from the cloud to the device, but the same constraints remain, right?
Agreed, exactly.
So we're having this very comfortable conversation about a shared vision for the future, but we're kind of ignoring some of the major limitations of LLMs today. They make stuff up and they replicate bias, and the models are primarily trained on text only, and most of the data in the world is not text. What's your sense of which of the very known limitations of LLMs today are going to actually constrain innovation for all the use cases you've been talking about?
I think one of the things that we are very conscious of is that concepts and issues like hallucination, which is where models tend to be extremely sure of themselves, but fundamentally wrong, factually wrong, and bias in data, these are very serious issues. And these are things that absolutely need to be addressed as we gradually take baby steps in that direction. Because if we don't get that portion right, it doesn't matter what else we do. This is going to be a technology that will have lots of issues as we move forward. We are very conscious of that. We have a role in that space. Keep in mind that a lot of it is directly related to anyone who publishes a model or generates a model. Well, they will have the first responsibility in making sure that it doesn't have these issues. Now, once these models are indeed generated, by the time they are published, by the time they get implemented in any device, we might or not modify the model just a little, just so that it makes sure that it actually fits within the envelope of power consumption or area and so on. And so there is a little bit of the responsibility that might or not come, depending upon what we choose to do with it. But we are not necessarily doing anything from the fundamentals of the data set in itself. We believe that those will be the first things that we want to address, and we are working very closely with our partners in that space. But that will be the first baby steps to make sure that this is a technology that indeed can be trusted and gradually starts permeating into devices. There's tons of other things that come in after that. But we're not afraid of change. We're not telling ourselves, okay, we got to pause everything and then hang on. No, that is not how it is. We're going to take it one step at a time, take deliberate steps in making sure that it is indeed a technology that end consumers can trust, and it is something that can be widely deployed.
It's a good answer. It's slightly unsatisfying, but I know that it's the best we can do right now, and I appreciate the focus on responsible AI. Now, the other thing that makes this conversation very easy is that we're not grounding it with any kind of a time frame. So, if we're having this conversation about what's going to happen in 2043, it's a different conversation than if we're talking about 2026. Give me your best prognostication. Along the span of, call it, the next 2 decades, when is some of this innovation going to be practical?
In this, the kinds of concepts that I was talking of, we easily see that happening very much within this decade. We don't have to wait 20 years for that. A lot of this is something that we are. It's a transformational moment in the industry in terms of simply the sheer capabilities of generative AI. And within this decade, this is now my personal prediction. Mind you, all predictions typically tend to be wrong, especially those of the future in high tech. I have seen this over and over again. None of us, I'll give an example of that, by the way. This is a wireless example. When we first started working on 4G, that was like in around 2003 timeframe. That was still 3 years before the state-of-the-art phone was known as the Motorola Razr, the thin phone. It was not a smartphone yet. And yet we were working on 4G. So I'm also humbled by the fact that our job is to actually work on the technology, not necessarily predict exactly what shape or form it's going to take up in the industry in itself. But that being said, looking at where we are today in terms of the capabilities of generative AI within devices, yeah, we absolutely see something happening within this decade in itself, where it's a fundamental paradigm shift in terms of how users perceive and use their devices. As for 2043, that's so far out there. It's very hard for me to predict anything in that. But I can pretty much say that at least in this decade, we'll definitely see a fundamental change.
You heard it here first. Within the next decade, LLMs running locally on your phone. Well, Durga, we'll have you come back when that's a reality, and we'll have another version of this conversation. Hey, we're about out of time, but I'm not letting you off the hot seat without answering one important last question for me. So think back to the kid that was getting his PhD at UCLA back in the 90s. What's your advice to that kid? I got to imagine you couldn't possibly foresee way your career has taken off. What would you say to that kid? What would be your advice?
Never stop learning. Just because you graduate with a PhD from a university doesn't mean you're done. Never stop learning. Remain inquisitive. Ask as many questions as you can. Don't be afraid of failure, because most ideas don't work, believe it or not. But you just gotta keep trying. That's about the one thing that I would say.
So seems like you've made continuous learning a hallmark of your career. Well, Durga, I hate that we're out of time. This one flew by, but I hope you will take me up on the offer. Come back and have another version of this conversation some other time.
Thank you for having me, Dan. It was a real pleasure.
For audience members that would like to learn more about you or the work that your team's doing, any place you want to point them to?
We will have, there's plenty of material that's available on our website. There's lots of, even some of the state-of-the-art demos that I was referring to will be available on our website as well. Feel free to go to qualcomm.com and check out our website.
Well, we're all rooting for you and the team to succeed. Thanks a bunch for hanging out, Durga.
Thank you.
Well, that's a wrap for this week on AI and the future of work. As always, I'm your host, Dan Turchin from PeopleRain. And of course, we're back next week with another fascinating guest.